Hello everyone. So in this video we will discuss about hashing data structure and we will see a basic introduction to hashing. So friends, before we start, in case if you are new to my channel, then please subscribe to my channel so that you never miss any update. So what do we mean by hashing? So before discussing that, we will see that why we actually need a concept called hashing. So usually when we need to perform any search operation, we have few options such as linear search, where what we do is, let's suppose we are given with this array of 10 elements, and let's suppose we want to search for a particular element, for example let's say 10. So in linear search what we do is, the value which we want to search, which is 10, we compare it with each and every element of this array, and when we reach here we find that 10 is there in this array, and we simply say the value 10 is found in this array. Also, let's suppose if we want to search for a value, let's say 20. So what we need to do here is, we need to compare 20 with each and every element of this array, and after comparing with the last element, if we don't find 20 in this array, then we simply return that 20 is not found. So here the problem is, in case if the key which we want to search is not present in this list or array, then the time complexity basically goes to O of n, because we need to compare the key with each and every element, and then only we can come to know that whether the key is present in this array or not. So this is one problem with the linear search. The other form of search we have is binary search. Now in binary search what we have is, let's say we are given with this array of 10 elements. In binary search, the array we have is already sorted. So here you can see, here the elements are sorted in ascending order. So when the elements are sorted in ascending order, we basically use this property to make this search quicker. So for example, let's say if we want to search for an element 8. So here we don't compare the key which we want to search with each and every element of this array. As we know that the array is already sorted, we take the lower index which is 0, we take the higher index which is 9, and using these two indexes we try to find the mid index. So here we simply do 9 plus 0 divided by 2, which give us 4.5, and if we take the integer value, the mid value will come to 4. So what we do is, whatever the value is at index 4, which is 10, we simply check that whether 8 is less than 10 or greater than 10. We know that 8 is less than 10, so it must be lying somewhere to the left of mid index, because here we know that the elements of array are already sorted. So what we do here is, we simply discard the right sub array completely, because we know that searching in elements after 10 will never give us 8. 8 will only come before 10. So we simply discard the right sub array. So after discarding the right sub array, our array becomes from 0 to 4, where we take 0 as the lower index and 4 as the higher index. We do 4 plus 0 divided by 2. We get 2 as mid index. So whatever the value is at mid index, which is 5, when we compare 5 with 8, we know that 8 is greater than 5. And as the array elements are sorted, we simply discard the left sub array, because we know that 8 must be lying to the right of 5. So now after we discard the left part, our array becomes of 3 elements from 2 to 4. And then we again find the mid index. We do 4 plus 2, which is 6. And if we divide it by 2, we get 3. So whatever the value is at third index, which is mid, we see it is 8. We come to know that we have found our key. And here you can see that compared to linear search, binary search works pretty much faster when the array elements are sorted. So friends, with binary search, with each iteration, we simply discard half of the array, because we know that the element which we want to search can be found at 3 places. One is at the mid index, or it can be on the left sub array or on the right sub array. So if it is on the left sub array, we simply discard the right sub array, and if it is on the right sub array, we simply discard the left sub array. So here you can see on each iteration we are discarding half of the array. So the time complexity of binary search comes out to be O of log n, which is pretty much faster than O of n. But here the problem still remains, which is there any data structure or is there any search technique which give us a time complexity of O of 1? Because searching an element in linear search takes O of n, which is not feasible for the search operation, and for the binary search takes O of log n. But here we have this constraint that element should be sorted, which is usually never the case. We have always elements in unsorted form, and if we want to sort them, we need to apply sorting algorithms whose complexity can reach to n log n. So after we sort the elements, then our search becomes faster and we get O of log n. So how can we achieve a time complexity of O of 1? So if you see, one solution is if we take array data structure. Now why array? Because array can be used to provide O of 1 searches using indexes. So let's suppose if we are given with these elements 6, 1, 3, 5, 9, 7, and let's say if we want to search in these elements and we want that the search should be of O of 1 time. So what we can do is, among these elements we will see which is the highest element, which is 9. So what we can simply do is, we can create an array whose last index is 9, which means we create an array of 10 elements where the last index is 9. And what we do here is, we take 6 and we store 6 at 6th index, 1 at first index, 3 at index 3, 5 at index 5, 9 at index 9, 7 at index 7. So we simply store all these elements into their respective indexes in an array. And let's suppose if we are given, let's search for a value 3. So what we can do is, we simply go to third index of array by accessing the array with index 3 and we see whether 3 is there or not. So this operation takes time complexity of O of 1 because we can access array elements directly. So here at third index we see that there is a value 3. So our answer is found. And let's say if we want to search for 0. So what we do is, we go to 0th index and we see there is no value. So our answer is not found. So friends, here you can see that arrays can give us a time complexity of O of 1 when performing the searches using their indexes. So the time complexity of this scenario will be O of 1, which is pretty much fast. So let's suppose we take one more example. Let's say we are in a classroom and we have this 30 students. So what we can simply do is, we can assign a roll number to each and every student and we can create a data structure which is array of size 30 where last index is 29, and we can assign the indexes to each and every student. And let's suppose we are storing a student object on each and every index. So here when these students are sitting in a classroom, the teacher can directly go to a particular seat, let's say 5, and let's say the teacher has a device where she can directly type 5 and gets the information for the student, that the student name is John, these are his marks in particular subject, and all of the information for the student John. And similarly, if she searches for 29, she can get the information for Tina. So here also we can use array data structure and we can get the time complexity of O of 1. So to this type of storage we simply call direct addressing. Moving ahead, now whatever the example we saw, their array was a perfect data structure for searching in O of 1 times. Now where the problem will still arise is, let's say if we want to store Aadhaar card number which is of 12 digits, or you can also take an example of storing the social security number in an array. So here if you see, that Aadhaar card number is of 12 digits and it gives an identity of a particular citizen of India based on his Aadhaar number. So the problem is, if we take an array to store the Aadhaar card number, then if we want to store this big number into an array which is nothing but direct addressing with its index, then there would be a huge array to store all the Aadhaar card numbers. So this is one problem, that we need to create such a huge array where the Aadhaar card number matches the index of that array. And the second problem is, let's say if the Aadhaar card number is designed with 12 digits and we have created a huge array to store the Aadhaar card number, and let's suppose we have only distributed 10 to 12 Aadhaar card to the people, and if we try to store those Aadhaar card numbers into the array, then after storing we will see that most of the memory of the array elements will remain unutilized and wasted. So this is the problem with arrays, where we can't use direct addressing because we need to store such a huge number. So to basically address these problems, hashing was introduced. Now what is hashing? So here you can see that hashing is a technique which is used for storing, retrieving and removing the information as quick as possible. And how do we perform the hashing is, here it is a process of converting an arbitrary size key into a fixed size value. So here what we are simply saying is, let's suppose we have our keys which are huge, let's say the Aadhaar card number or social security number. So what we can do is, we can't directly store the key into the respective indexes of the array because that problem we discussed in our previous slide. So what we do is, we take that particular huge key and we try to convert that key into a fixed size value. And how we perform this conversion is, this conversion is done by a special function which we call hash function. So we will discuss hash function in our upcoming videos. But for time being, we can think that let's say if we have array of 1000 elements and we want to store a 12-digit Aadhaar card number. So what we do is, we take the Aadhaar card number which is of an arbitrary size or a huge size, we pass that number to our hash function, and this hash function will give us a fixed size value. Let's say if we are taking the size of the array where we want to store the Aadhaar card number is of 1000, then it will give us a fixed size value between 0 to 1000, and we can simply use that fixed value and store that particular Aadhaar card number. So this conversion of a large key into a fixed small size is done via hash function. So we will discuss this hash function in detail in our upcoming videos. So for time being, you can simply think that hashing is a technique which is used for storing, retrieving and removing the information as quick as possible. And the operation which hashing supports, such as storing, retrieving and removing an information, have average runtime complexity of O of 1. So friends, in this video we saw that why we actually require the hashing technique, or why we require a hashing data structure. Because we need average runtime complexity of O of 1 when we want to store, retrieve or remove any particular piece of information. So in our next video, we will see that what are hash functions and how it helps in converting a huge size key into a fixed size value. So friends, in case if you find this information useful, then please like this video, and if you are new to my channel, then please subscribe to my channel so that you never miss any update. Thanks, have a nice day.